Hello and welcome. This is Getting Into JavaScript. I'm Kyle Simpson. A lot of you I know and either know online or in person. So if you find me online, you can always look for Getify. That's my Gmail address, my Twitter, my GitHub. There's lots of places to find me online. So anytime that you are going through this course or afterwards reviewing things, feel free to find me online under Getify and reach out with any feedback, questions. I love getting to help people learn about JavaScript. This is what I do for a living. I just travel all over and teach this kind of stuff. And it's a particular joy to teach this exact course because getting into JavaScript is really the bootstrapping, if you will. It's the first steps for some of you, maybe never having done any programming at all. And that's really exciting to see because we know that a couple of years from now, you'll be mid and senior level developers at amazing jobs. And it's cool to be part of those first initial steps. So I'm excited to jump into that journey with you. Let's dive in and let's start talking about JavaScript. We'll first actually look at programming and then programming specifically in the context of JavaScript. As a companion to go along with this course, I want to point out one of the books that I've written. This is in the You Don't Know JS book series, and many of you know about that series. You can read the entire 6-book series for free online, and there's a link to the GitHub repo here in the slides. But they've also been published officially as regular books, so you can find those any place that you buy books online, like Amazon and so forth. But the first book of that series is called Up and Going, and I wanted to just sort of frame that book. So the first chapter of that book is about, I've never done any programming before. What is a program? What is a line of code? What is a statement? And if you're in that boat, that's exactly where chapter 1 was written for you. And the first part of our discussion today, we'll kind of quickly review some of those basic concepts, just in case any of you have maybe never heard some of those words like statements or expressions before. But this book should be seen as a companion to this course to help you sort of as a roadmap go into more detail on any of these topics. So if we say something, if we move a little too quick on something, make sure you dive back into the book. Chapter 1 is all about I've never programmed before, and chapter 2 is all about, oh, I've done some programming before, I understand if statements and for loops, but I've never really done anything with JavaScript. What do I need to know to really get up and going with JavaScript? That's what chapter 2 is all about. And it goes into all the things that we'll cover today, but in much more detail. So look through chapter 2. And then finally, chapter 3 of this book, that's it. It's only 3 chapters, like 70 or 80 pages long. But chapter 3 of the book is all about orienting you to where to look for more information throughout the rest of the series. So it covers each one of, or highlights and overviews, each one of the things that all the other 5 books in the series focus on. So I definitely encourage you to go and either read online for free or pick up a copy of this book and use this as your companion guide as we go throughout the course. The most common thing that people talk about when they talk about starting a new programming language or starting the idea of programming or maybe a new framework, a new tool, is the hello world. How do I make it say hello world? And I wanted to give you just a quick glimpse of a sort of hello world-ish kind of JavaScript program. Obviously it doesn't literally say hello world, but it's just a quick glimpse. And by the end of our discussion today, you should be fully and completely confident in this sort of code, being able to write this sort of thing for yourself in JavaScript. So we have a couple of things that are starting off right at the beginning. We've got a variable called teacher and another one called Twitter handle and another one called age. And then we have this thing called a function, the function who am I, that takes some inputs. Those are called parameters. You see on line 6 a console.log. That's how we print things to the developer console. And then down on line 12, the who am I, that reference is actually calling the function. So if any of those things that I just said in the last 20 seconds were like, wait, what, calling a function, what does that mean? Don't worry, we're going to get into all of those things. So this is the kind of code that we want to be able to dive into and be totally confident on so that it's our foundation for exploring the rest of the language. So that's our motivation for this course that we're going to dive into today. But before we move on, let's actually see that code running. I've got that code loaded up in a Run.js environment. This is one of my favorite ones. You can, of course, also use something like a Chrome console, the developer console, or even use on the command line something like Node.js. But I'm going to run this code. You'll notice I have the teacher, Twitter handle, age, the function. I'm going to run this code, and we'll see the output here on the right. You'll notice that it has printed out a string. Hi, I'm Kyle, aka Getify, and I'm 39 years old. Now, if I had done this workshop a few months ago, back before my most recent birthday, and I was 38, if we change that value and we rerun it, you'll notice that the value changed. Or if I, for some reason or another, decided to change my Twitter handle to the Getify, then we could change that value, and now you see the value changing every time we run it. So that's an example of the kinds of things that you're going to want to play with as you go throughout this course. You're going to want to try the code, but it's most important that you write the code and then run it. So make sure you're familiar with one of these environments where you can execute the code and see those results hands-on for yourself. As a quick overview of what to expect, we're going to start, as I said, with a quick primer on programming concepts. And we'll look at things like statements and expressions and variables. So we'll fill in any gaps that may exist for you there. And then we're going to dive into what I consider to be the 3 pillars of the JavaScript language. This is only my opinion on how to divide up the various features, but I think these are the 3 main areas that you'll spend focusing. And just to set some expectation, these are not things that you learn in one day. You could take one of these units and spend weeks or even months, potentially even years learning. I'm 20 plus years at this, and I'm still learning bits and pieces and figuring these things out. So really the best way to approach this is not like I want to check something off in my spreadsheet, but really I want to approach this as a continual, ever sort of learning thing. You're starting out in a journey to learn how to do programming, learn how to do JavaScript, and I want you to embrace that as a constant thing that you will journey throughout your entire career. So the 3 pillars that we want to look at, number 1, we're going to look at types and coercion. And again, if those words don't make sense, don't worry, we'll talk exactly what all of those things mean. But we're going to look at scope, and scope enables us to talk about closures, which is a very critical feature. And finally, we're going to look at the this keyword and the prototypes. And so if you've never heard of any of those things, that's great, you're in the right spot. Maybe you have heard of some of those things, but they're confusing, or you've just seen them used in a library or a framework or on a Stack Overflow post. You weren't really quite sure what they meant. We want to take a little bit of a deeper dive into it. And again, just as a reminder, the book is where you go next after anything that you've learned here in this course. Go into the book. It'll start to give you more of that information, and then it'll push you into the rest of the book series, which dives really deep into each of these topics. Before we go on, though, I want you to hear a little bit about my thoughts on why we code, which is that we code so that the things that we write are readable to human beings. So let's dive into a primer on basic programming concepts. And here's a quick list of the concepts that we want to look at. We'll look at 1 or 2 code examples for each one of these to sort of illustrate what does that mean and where does it fit in the overall scheme of things. Just like if you were an English major, you need to learn about the English language. Well, we need to learn about the process of speaking a language, and we are going to do so in the context of JavaScript. Obviously, that's what this course is about. But these are the basic things that you'll actually find in any programming language. So if you have done a programming language before, in your mind, you'll think, oh, I know, I used to do a function this way in that language, and now that's how I do that in JavaScript. So look for those sorts of connections. And if this is your first programming language, you'll be able to take these as your foundation and use those to learn in another programming language at some point. So we'll look at values. Those are things like the number 42 or the string hello world. We'll look at operations, things that we do like 42 plus 1. We'll look at variables, which is where we store those values and then where we access them later. Expressions and statements, that's really, again, back to the sort of English grammar. An expression is kind of like a phrase in a sentence, and a statement is a whole sentence with a period at the end. We'll look at decisions, deciding whether or not to do something or to do something else. We'll look at loops, repeating things over and over and over again. And finally, we'll look at functions. These are the building blocks that make up a program, that make up the logic, the instructions that we give to the computer through our programming. So let's dive in. Values. Here's an example of a variety of values that you can express, again, in a JavaScript program. Line 1, you see just the number 42. Line 2, you see 3.14. Now, there might be a temptation to think that those are different kinds of values because one of them has some decimals on it and one of them doesn't. In the JavaScript language specifically, there's no distinction between numbers that have decimal places after them and numbers that don't. So 42 and 3.14, those are both just numbers. Some languages will distinguish, and they'll say something with a certain number of decimal places is a particular kind of number. But here we're just going to talk about numbers. Then on line 4, you see those double quotes that are around it. And by the way, you could use double quotes or single quotes, so you'll see a variety of different styles of coding as you explore. I just chose to use double quotes to illustrate. This is what we call a string. A string is a collection of characters that make up something that we could sort of, in English, actually pronounce. We could say out loud. It's sort of like a word or a sentence, a set of characters that go together. And so we're basically saying, this is how I can put together something that I might print out a message to the screen or write some information to a file. That's why we use a string. Now you notice on lines 6 and 7, we have values like true and false. Those two values go together in a sort of kind or a class of value called Boolean. Boolean is actually the name of a famous mathematician from hundreds of years ago, George Boolean. But we get this idea of true and false. And you may have heard that computers work in a bitwise with zeros and ones. There's a same kind of concept here, that it is either one or the other. It can't be anything other than those two values. So if you have a Boolean, it's either true or it's false. And then you'll notice null and undefined, those two values, those are two different kinds of what we call empty values. Now, empty value is a little bit strange. Like, what does it mean for there to not be any value, or to sort of a placeholder for some missing value? But it's a really important concept in programming, and each programming language has their sort of own flavor of what it means to have emptiness. Either something that has never been given a value, or something that used to have a value and it doesn't anymore. There's sort of an emptiness. It's a little bit of a strange historic fact why JavaScript has two of them. It might seem like we only need one, like either undefined or null, but there's some historical reasons why we end up with two of these. My general recommendation is for you to try to do your programming in such a way that makes those sort of indistinguishable. Don't really try to get too wrapped up in, oh, I need a null here, but I need an undefined here. There are a couple of places that you may run into where the distinction is important, but for the most part, null and undefined, they're just kind of two different ways of saying this thing is empty. There is no other value here, so we're just denoting the fact that there's a kind of emptiness to it. Now, lines 12 and 13 get a little bit more interesting, because on line 12 and 13 we would move out of what we call primitive values, like we've seen thus far, into these non-primitive values. And all we mean by primitive is that it's like literally written as an actual value, rather than a collection of values. So you notice on line 12, that's what we call an array. An array is basically just an ordered set of lists. I have a favorite little anecdote about this. My son, when he was like 2 or 3 years old, I got one of these books, and it was called A is for Array. It's a great little kid's book to teach kids about programming, and it uses the alphabet. It assigns a different programming term to each letter of the alphabet. And I remember we got to A is for Array, the very first letter, and I was trying to help him understand this concept. They do a good job in the book, but I was trying to help him understand the concept. And what we did was just line up some blocks on the ground, and I was teaching him this whole idea about arrays. And arrays are what we call zero index, meaning the first thing in the array is actually at position 0 rather than maybe what we might assume is position 1. There's a long historical reason why that's true in computers. But I was trying to help him understand this idea of zero indexed into an array. And so we lined up several of his blocks, and I remember playing with him, and I'd say, all right, now pick up block 0. And he would pick up the first one. Then I'd say, pick up block 1, and he'd pick up the one right next to it. So that's basically what an array is, just an ordered collection of these values. And they have these kind of numeric association because of where they are, where is their position. That's how we go and get something. So if I wanted to get the value 3 out of the array, I would basically need to get the value at position 2. Rather than at position 3. And those values, of course, can be anything. I've got numbers here, but they could be any of those other values, like numbers, strings, booleans. In fact, they could be even other arrays. Or they could be objects, like we see on line 13. Now, on line 13, it's a little bit different than an array. It's also a collection of values. It's not a primitive single value, but a collection of values. But it's a different kind of collection, because rather than the values being in positions that are like numbers, like position 0 or position 1, these values are at positions that are given names. Almost like you have an address at home, and that's a specific location within your neighborhood and within your city. The mailman knows exactly where to go to deliver the packages or the mail. A key is what it's called inside of inside of an object, otherwise known as a property. It's a specific named location, and we use a string. So you notice here I have name. That's the literal key name or property name for this particular position in an object. And I could have either surrounded that property or that key with string with the double quotes, or not surrounded it, as I did here. Most of the time you don't surround it with quotes, but every once in a while you need to. And then on the other side of that colon, that's where we have a value. And here I chose to put the value Kyle, but of course it could have been any other value, like a number or another array or another object. So these are the kind of basic building blocks in any sort of programming language. You have values. You need to do things with those values, and we'll get into that in just a little bit, but you have to first understand how to represent some concept that you have in your head. If you're doing something that is mathematically related, like maybe adding up the amount of money to charge somebody for an order, of course you need values that are numbers. And if you have a message that you want to print to the screen, of course you're going to have strings that you're going to be manipulating and working with and adding together or moving around or things like that. So these values represent tasks that we want to accomplish. And they have sort of intrinsic behaviors associated with them. You can do math with a number. You can't really do math with a string. That doesn't make sense. But there are operations that you do with a string that don't really make sense for a number. So what are some of these operations that we might want to do with our values? Well, you notice here on line 1, I've got a 3 and then a plus and then a 4. So I've got two numbers that I want to add together. Or I've got the number 43 and a minus and a 1, and I want to add those two numbers together. I mean, subtract one number from the other. Okay, so those are basic arithmetic, if you will. You probably learned this back in kindergarten, first grade. Basic arithmetic that you can express in your programs. And you don't often write that out literally like 3 plus 4. Often those values will be inside of variables, and we'll talk about that in just a moment. But it is possible for you to just do straight up math or any other sort of operation. Like, for example, line 4, you'll notice that I also have a plus operator, but I don't have numbers here, I have strings. And one of the peculiarities of JavaScript is that it uses the plus operator to mean two different things depending on the way, what kind of values we've got in the operation. And so when we have string involved in the plus, we do what's called a string concatenation, which is like just smooshing two strings together. That's all it means. And when there's two numbers involved, that's math. So that plus operator, there's a fancy term for this in programming. It's called overloaded. It means that it has more than one kind of behavior depending upon the values that are involved in it. By the way, I keep talking about involved in. What do I mean here? Well, operators have what are called operands. And an operand is the value that is going to be operated on by the operator. So on line 1, 3 plus 4, the operator is plus. It's an addition, a numeric addition. And the two operands are 3 and 4. Oftentimes we might refer to them as the left operand, which would be 3, and then the right operand, which would be 4. Those kinds of operators, ones that have a left and a right in terms of their operands, those kinds of operators are called binary operators. And binary is just a fancy term for it means there's two involved. So we have binary operators like plus and minus. But you notice on line 6, I've got a special character, the exclamation mark. That's a different kind of operator. That's what we call a unary operator. It means, unary means one. Kind of like in Spanish, uno means one. You can think unary means one. So unary means a single operand involved in the operation. And here we have the false. The exclamation mark does what we call flipping of a Boolean value, or the negation or the complement of a Boolean value. So remember how I said Booleans can only be false or true. So if we start out with false and we want to flip it to the other one, we're going to get true. And if we were to start out with the exclamation mark and true and flip it, we'd get false, right? Now, line 8 shows a different kind of operator still. It is a binary operator, but it's not actually producing sort of a different kind of value. Here it's doing what we call comparison. It's saying, does the value on the left-hand side and the value on the right-hand side, do they have some sort of relationship that we can determine something about? In this case, we're using the double equals operator, which is the equals, or what we call the loose equality operator. It's saying, are these two values equal to each other? By the way, you may have heard in equality, and we'll get into this in a little while, you may have heard in equality in JavaScript that there's two different equality comparison operators. There's this double equals one, and then there's the triple equals one. And there's a lot of nuanced distinction between the two. I'm going to try to help you juggle some of that later in our discussion in this course. But for right now, you should know that in this particular case, they wouldn't have done anything different. We would have gotten the exact same result between a double equals and a triple equals, because both of them are numbers, so no changing of value types is even involved. They would have done exactly the same thing. So 3.0 and 3, if you remember when I talked about values a little while ago, 3.0 and 3 are the same kind of value. They're both numbers, so they're equal to each other. Even though in our programming code they look slightly different, they're actually basically the same number, so that comparison would tell us that they are equal. It would return us actually a Boolean that would say true. Line 10 is another kind of comparison, which is less than. And we know that the number 3 is clearly less than 4, so again, when we do that kind of comparison, we would have gotten a Boolean true back as well. Now line 12 shows us yet still a different kind of operator, and these are sort of conditional operators that are, I'm sorry, not conditional operators, they're logical operators. They basically try to decide something for us. So the double vertical line there, that's called the OR operator. The single character is called the pipe character on your keyboard if you haven't seen that before. When we put two of them together, that's called the OR operator. And so it's basically saying, tell me if one or the other of these results in something that we would call Boolean true. If one or the other results in true, then I want to know about that. Otherwise, we won't do something. And when we talk about making decisions in a little while, you'll get a sense of why you might want to do something. If one or the other of these things is true, do it. And if not, do something different. So the double pipe operator is what we call OR. And there's a complement to that one called the double ampersand, that little squirrely character that nobody can ever write. That little double ampersand operator is how we say and. So that would give us a true only if both of the things, both of the operands, were true. So now you're starting to get a sense that there are things that we want to do with our values, and the things that we want to do are the kind of operations that we're going to perform. Before we move on, I want to actually let you see those expressions, those operations that we were just talking about actually being evaluated. So you can see here that 3 plus 4, it evaluated to 7, and 43 minus 1, it evaluated to 42. And when I concatenated these two strings together, you see the string Kyle Simpson. The negation of false, or the complement of false, it evaluates to true, and 3.0 equals 3. Oh, and by the way, even if I did a triple equals, it's still true, because it's not about type coercion, it's just that JavaScript treats these numbers as the same. We can see that 3 less than 4 is evaluating to true, but if I were to flip that around and say 4 less than 3, now all of a sudden that one's going to change to evaluating to false. And finally, true or false, of course true or false is going to evaluate to true, but if I changed it to the double ampersand, now all of a sudden that one results in false. So definitely make sure you're familiar with how these things are evaluating. It's not always so great to do it in your head. Sometimes it's great to just run it in the JavaScript and see what you get. Now, I've been referring to kinds of values, but we need to get a little bit more specific about that, because there's a term in programming language speak for the kind of a value, and it's referred to as its type. A value that is a kind of number, that's going to have a type called number, and one that's a string called string. So the type of that you see here placed in front of the number 42, or the type of line 3 placed in front of that string Kyle, that's actually also an operator. Type of is a unary operator where we give it a thing and it tells us what kind of thing we're dealing with. And this isn't that important when you're dealing with you wouldn't really do type of 42 because you already know it's a number. But again, when we talk about variables in a moment, you'll see that we may not know what's in some variable, and a type of is really important to help us know, I have a number here so I can do math with it, or I have a string in this one and I don't want to do math, I want to do sort of printing messages to a console or something like that. So you'll notice that each of these values we've talked about have a different kind of return result from this type of operator. And down at the bottom, you'll notice that we have kind of some special cases where, remember, null was one of those empty values, similar to undefined, but here the type of operator, line 7 versus line 12, it returns us different results. For undefined, it gives us that string undefined, but for the null, it perplexingly gives us the string object. And really, that's just a bug from like 20 plus years ago in JavaScript. Unfortunately, the way the web works, we can't really always fix bugs in a language because then we might break other stuff. So that's just something that we've had to work around for the last 23 something years now. But notice line 13, we said that's an array, but when I do a type of, I don't get a specific kind of result that tells me it's an array, it just says it's an object. That's not a bug, that's just a less specific kind of an answer than we might prefer to get. We might have liked for it to say array. But what we're getting at there is that there are values that can be sort of subtypes. An array, which has a very specific behavior, remember the numeric positioning, but it's a subtype of the object type. So that's why it's returning to us an object. And it turns out there are other operations that we can do to figure out more specifically, okay, well, you tell me it's an object, but is it a regular object or is it a special array object? We can determine those things, we can distinguish those things using other kinds of operations. This is something you're going to need to do in almost every programming language that you ever write in, is you're going to have values, and again, values have different things that we do with them. We do math with something like 3.14, and we do printing to a string, to the console or a file if we have something like string Kyle. Those are all distinguishing things that we have to do in any programming language. And they're all basically under this umbrella of determining the type of the value we're dealing with. Now, I've said this several times, so let's get into what is a variable. A variable is like a place in memory. You know in your computer that it has memory, what we call RAM, and as a program is running, it uses up and it stores bits of information all over the RAM, and we don't know where it's being stored. As a matter of fact, our program has no idea where it's being stored. The system, like our Mac OS or Windows, it's figuring all that out for the program, and so we need a symbolic representation. Kind of like a pointer or an address or whatever sort of metaphor you want to have in your head. It's a representation of some place in memory. We don't really care where it is, but we know that our number 42 is going to be over here, and we know our string Kyle is going to be over here. And the way we do that inside of our program is we give those things useful names. So we already saw this at the outset in the intro, but if I say var name equals and then quotes Kyle Simpson, name is going to point to somewhere in memory. We don't know and we don't even really care where, but somewhere in memory, and it's going to say the equal sign there is going to take that string and put it in that place in memory. And then later, if we want to access that, we would use the variable name again, and it would give us that string back. It would go and find it in that particular place in memory and give us the string back. By the way, just a quick note on operators. You'll notice here we have a single equals. That's called the assignment operator. And the single equals being used for assignment is why we have to do double equals for comparison. I know some of you might have been thinking, why don't we just say A equal B or 42 equal 42? Well, it's because we have the single equals reserved for assignment in our language, and that's why we have double or a triple equals to do comparison. It can sometimes trip people up where they meant to do 1 equals and did 2, or they meant to do 2 and did 1, so something to be aware of. Line 3 and 4 are slightly different than line 1, because in line 1 I both said that I needed a variable of the name, but I also assigned it a value right away. I said, go and create this location in memory and give it a value. Line 3 does something slightly different. It says, hey, go give me some area in memory, but I don't know what I want to put into it yet, so just give it one of those empty values. In particular, it's going to give it the undefined empty value. And then later, which just happens to be line 4, we're going to give it a value of 39. That's how old I am at the time right now. So we're putting in the value 39 into that location of memory that is referred to in our program as age. Line 6 does something very similar, but it takes an array of values. And so it would have to, the program and the operating system would have to go figure out a bunch of places in memory, one for the quote Brandon and one for quote Mark and for any other values that were in that array. And I've got to section off all this memory and then have one reference to that whole section of memory. And that reference is what we call friends here. Now, line 8 does something interesting, and it's tempting to sort of skip over. But before we even look at the friends.length or the friends with that square brackets of 1, let's look at the console part, because that's also a variable. Console is referring to a special built-in thing that the JavaScript environment is given by the browser or by Node.js or wherever you're running your JavaScript. It's given this thing called console. It's a special area in memory with a very special set of behaviors attached to it. And when we do that dot operator there, on line 8, we're basically saying, I want to go and access something in that location at a certain name called log. Well, log happens to be a method, a function that can print things to our developer console. So we're actually saying, go find console, wherever that is in memory, and then access it. And then when we say .log, we're saying now access something inside of it. And then we are telling it what to print to our console, and that's why it says friends.length. We're saying go find the friends thing, which we know is an array from line 6, access something at that location, which isn't just like a position like 0 or 1, but it's called a property. Remember, arrays are objects, so they can have properties, and one of those special properties is the length. And that length would tell us that our friends array at this time has 2 elements. It would say length 2. So we're saying print whatever that value is, and in this case it would print the value 2 to the developer console. And then line 9, we do something very similar. We say console.log, and then we say friends bracket 1. Remember, I referred to the idea of arrays, and we declare an array like line 6 with square brackets, but when we say a variable and a bracket immediately after that, now we're saying access it. Line 6 is creating an array, and line 9, the bracket 1 there, that's accessing something inside of that, kind of like the dot operator, but in this case we're accessing a numeric position. So friends bracket 1, that's going to return Mark, not Brandon, because the array is 0 indexed. So these are how we refer to these values, even though they're going to be stored in all kinds of random places in our memory. These are how we refer to them and keep track of them, how we deal with them and how we manage them inside of our programs. A couple of other operators that I just highlighted here. You'll notice on line 8 that parenthesis, the open parenthesis. That's also kind of technically an operator, and it means function call. Actually, parentheses can be used, it's another one of those overloaded cases. It can be used to mean lots of things. When it comes immediately after a variable like log, it means execute a function, but it may show up in another operation where it's just grouping things together. Like you might put parentheses around 1 plus 3 and then do something else with that number, like multiply it by 6. And that's a grouping, and you may remember that from math class, kind of grouping things together to decide what things happen before what other things. So we have the parenthesis operator, and then up on line 1, we have that little bizarre semicolon. What's the semicolon about? Well, that's also kind of an operator. In this case, we're not really doing anything to a value, but it's just a part of the syntax that is denoting that we finished a statement. It's very similar to if I just used an English sentence and then I finished, and there would have been a period at the end of that sentence when I finished. And it's very similar in programming. We are telling the program, I don't have anything else to say in this particular sentence, so this sentence is done. Before we move on, let's actually execute that code and make sure you understand how those values are being pulled out of that array. So I've got it loaded up here in Run.js, and I click Run. And you'll notice that the first console log statement says 2, because there are 2 elements in the array. That's the length of the array. And friends bracket 1 gives us Mark. But if I were to change this array, if I were to add my friend Alex to the beginning of this list, and then we run the code again, you'll notice now we're going to get 3 as the length of the friends array, and now friends bracket 1 is pointing at Brandon because we've changed the relative position of the values in that array. So again, this reemphasizes why it's so important for you to be able to run the code and see how it works. That concretely cements in your head how JavaScript is actually executing the things that you're writing. Now, there are other kinds of operations that we're going to do that can only be done with actual variables. So we talked about some operators before, like the plus and the minus and the exclamation mark. Those can be done even with values, like you saw with the number 42 or the Boolean false. But we have some operators which can only be used if there's a variable. And it's because these operators not only do something, but then they reassign. They set a value back into that location. So line 3, we have the plus plus operator, and it is saying, go and increment, add 1 to whatever is in age, but also you should reassign that value right back to age. So it would have been similar to if we'd said age is equal to age plus 1. Go compute whatever age plus 1 is, which in this case would be 40, and then assign that back into the variable age. Line 4 does something very similar, except instead of only incrementing by 1, the plus equals allows us to tell it how much we want to increment. But because the equals is there, you can see very clearly there's going to be a reassignment back. So now we will have moved age from the value 39, we will have reassigned it the value 40 on line 3, and then on line 4 we will have reassigned it a new value, which would be the value 42, which is why on line 6, when I just have a variable reference there, I'm just basically saying what's in the variable at this place, at this moment, in the memory somewhere, what value is in that location? Well, it's the value 42. I've used these terms expressions and statements now several times. Let's make sure we're very clear about what an expression or a statement is. Just like in the English language, an expression is like a phrase. Like if you say the sentence, I am a friend who likes to play ping pong. The phrase, who likes to play ping pong, is not a whole sentence. It's just a part of a sentence. It's a phrase, it's a fragment, if you will. In programming speak, we call that an expression. And then we take the entire thing from the very beginning to the final period or question mark, and we call that whole thing a sentence, and in programming we call it a statement. A lot of times there's not a big distinction between expressions and statements, but sometimes it is kind of an important deal to keep them separate. So in line 1, we have a statement. It begins with this var keyword, which, by the way, that's how we tell it, I want to make a variable. And then it ends like a period in an English sentence. It ends with the semicolon. So that's a whole statement. It's a whole sentence that is saying something that we want to have happen. But there are parts to it, and in particular, one of the parts is that age equals 39 part. That's what we call an assignment expression. So we can think of that as a phrase or an expression inside of the whole thing, which is the statement. And on line 3, we see an even more complex sort of statement. Starts with the age at the beginning, ends with the semicolon at the end. Almost all statements will end with a semicolon, unless you're dealing with a coding style which likes to leave those off. It'd be kind of like if you were reading Shakespeare and you had no punctuation in it. You might get a little confused where the sentences are. So some people like to do that, but most people like to put the semicolon there. So that's where you know it's at the end of the sentence. It's the end of the statement. But what are the expressions here? It turns out there's several, more than you might have realized in terms of counting things. So let's look at it. The number 2 on the right-hand side, that is an expression. It happens to be called a literal expression. Remember, we have those primitive values. Those are called literals. So the number 2 is an expression. And the variable age to the very left of it, that's also an expression, because we need to go get whatever's in it, in this case the 39, and do something with it. So we have 2 expressions already. And then you'll notice those parentheses. Remember, I was just talking about grouping. Well, we've got a set of parentheses wrapped around age times 2, times being the multiplication operator, that little asterisk there. That age times 2 with the parentheses around it, that's another expression. So now we have 3 expressions. And then there's an expression for the literal 1. So we have a 4th expression. And then we have the expression 1 plus, and then whatever age times 2 was. And so that's a 5th expression. And then we have the age equals whatever has been computed there. That's a 6th expression. All 6 of those expressions are part of this one single sentence statement that we call a programming statement. Now again, it's not always that important that you go count all of the expressions, but it's at least important that you be aware of the idea that a single statement is often built up with lots of individual expressions. All right, let's try out those expressions and statements and make sure we see how they're being evaluated. If I run this code, you'll see that it's giving us age 79. If I were to take that specific expression and just ask what was age times 2, let me comment that out for a minute. If I ran age times 2, you're going to notice that it was 78. And then that's when we added to 1 to get 79. And if I say age times 3, now of course we're going to get a different age outputted. All right, so we want to do something useful with our programs. We don't want to just say the number 42 and then add something to it. We want to actually do things, and the way we're going to figure out how to do things is we're going to have to make decisions. We're going to have to decide if the user has added some item to their shopping cart and they want to check out on the Amazon.com or whatever. We're going to have to decide if that item is in memory, if that item is in inventory so that we can sell it to them. We're going to have to make decisions. And the primary way that we're going to make a decision, there are other ways to do so, but one of the primary ways to make a decision is called the if statement. So here we see line 1, that should look familiar. We're making a var age equals 39. That's an assignment statement if you remember. But line 3 is slightly different because we have the if keyword, and then we have a set of parentheses there. That's what we call the if clause or the test clause. And then we have some stuff that we're going to do inside of those curly braces. You see there's a curly brace at the end of line 3 and then another one at the end of line 5. They kind of group together a set of statements. That would be kind of like a paragraph in a novel that you were reading. We would group a set of sentences together into a paragraph. We group a set of statements together with curly braces. So we're saying if age is greater than or equal to 18, then we want to do everything that's inside of these curly braces. So we need to figure out what the result of the operation age greater than or equal to 18 is. And remember, greater than or equal, that's one of our comparison operators. So it's going to go make a decision. It's going to go say, yes, it is greater than or equal to 18, in which case it gives us true, or no, it isn't, in which case it gives us false. And the if statement then says, I'm only going to do the work inside of the curly braces if I got a true back. That's how we make a decision. Now, it's sometimes the case that we only want to do one thing if some condition like this is true. We want to make a decision and then do something. But a lot of times it's like we need to choose between two different things. We either need to do this or we need to do that. And that's a slightly different variation on the if statement form called the if-else. So if looks exactly the same, lines 1 through 3. You see the if. You see an expression there, which in this case is a function call. That's going to either return us something that looks like true or something that looks like false. If it returns us true, then we're going to do the stuff on line 2. But if it returned us false, immediately we're going to skip over that stuff and go right to the else clause. And the else clause then executes only if the test clause returned false. So now you see the basic building blocks for making decisions. We can either do something or not do anything at all. Or in this case, as we see on this slide, we can do one thing or do another thing depending upon some condition. And you can chain these things, you can nest these and put these things together, kind of like when you build, with Legos. You can put all of these pieces together and you start to build up more and more complex things in your application. Okay, let's test out how that if-else stuff works. Here I've changed the code just a little bit. I've got instead of calling functions, I'm using a Boolean variable here. But if I run this code, you're going to see because enrolled is enrolled is true, it's going to take the class. But if we change that to false, now all of a sudden it's going to print a different message, which is enroll first. It is often going to be the case that you have several different operations that you need to do multiple times. And that's where we get loops. Loops are the way that we repeat something over and over and over again. So here, let's say that I had an array called students, and all I've done there on line 1 is just leave out what values that I might have put in it. And by the way, if you haven't seen that syntax with the little slash star and star slash thing, that's just a comment. That's why it's grayed out. That's just a little inline comment. And all I'm signaling to you is there's a bunch of values there that I didn't have space on the slides to type in, but they could have been numbers, strings, who knows. Okay, so that's an array that has some set of values in it, and what we want to do is say hi to them. So let's say that all of the values in this array might have been the strings that were all of your student names, like Matt and Sarah and all the rest of them. They all would have been listed in there individually. Okay, so if we were to say for, which is what we're doing on line 3, we're basically indicating, hey, I'm going to repeat something a bunch of times. And there's two different ways of doing a repetition with the for loop that we're seeing here. One on line 3, one on line 7. So we'll take each one of them and split and focus on them. The line 3 block of code, line 3, 4, and 5, that is saying I want to do something where I'm going to count how many times I do it. So we do let I. Let is just another way of creating a variable similar to var, but it makes it in a smaller block of our code, in this case only inside of that curly brace, paragraph if you will. But it's the same kinds of concept as making an I, and we're initially going to start it at 0, and then notice on the very far right hand side we've got an I++. That I++ says, remember that we want to update it by 1, we want to increment it by 1 each time. And how do we know when to stop the loop? Because we don't want to let the loop run forever. How do we know when to stop the loop? It's the stuff in the middle. You notice that there's a clause, and these are separated by, see the semicolons? They're separated by semicolons. The thing in the middle is what we call a test clause. And it's identical in its behavior to what we put in an if statement. So it's yet another way of making a decision. Here the decision is, should I keep the loop going, or should I stop it? And we're going to reevaluate, we're going to relook at that expression every single time we do a loop. So we're going to just keep repeating and repeating. It's kind of like if your kid was jumping jump rope, and they're just going to keep jumping and jumping and jumping, and at some point they're going to get tired or whatever. I mean, I can do like 4 or 5 jump rope cycles before I get tired. But they're going to keep going and keep going until they get tired, and then they're going to stop. And it's the same thing here. We're going to loop and loop and loop until we have decided that it's time to stop. How do we decide here? Well, it's if our little counter that started at 0, if it has gone through all of the students. We've looked at students.length, and maybe that was like 15, because there's 15 of you here. Well, it's going to go through all of those students, and then when it's done, then it says stop the loop. And for each time that we do the loop, we're going to call this function greet student just to say hi. So hi Matt, hi Sarah. We're going to do each one at a time. And the way we get out those values from the array to tell it who to greet is that students with the square brackets of I. That looks exactly like when we did square brackets of 1, but now we're telling it specifically which position to get based upon that little I variable that's going to be counting from 0 up to, in this case, 14. If we went from 0 to 14, that is 15 items or 15 iterations, 15 times that we've done the loop. Now line 7 is a slightly different kind of loop. It's a for loop that is going to go over a list of values. So you notice I have this let student that's going to get assigned automatically by this for of loop. It's going to get assigned each value out of the array. So I don't need to go access it by a position. It's just going to automatically tell me, give me all of the values that are in this student's array. There's a very technical term for this. This is called an iterator, that it's going through a value source like an array and just getting all of those values out. But these are two very common loop forms that you'll find when you're seeing JavaScript programming. They're not the only kind of loops, though. There are while loops, for example. A while loop is similar to the for loop, except you'll notice that we don't set anything up like an initial value, and we don't increment anything. We just have a single clause there, a single expression, students.length greater than 0, and it's just evaluating either to true or false. And the while loop says, keep going while it evaluates to true. So if there were like 1,000 of you in this room, this would be a really crowded room, but if there were 1,000 of you in this room, we just keep going 1,000 times, from 0 up to 999. Well, actually, we're not counting anymore since there's not a for loop. What you'll notice here is that we're checking to make sure that students.length still has items in it. That's why we're saying greater than 0. So what's happening here is actually kind of sneaky. On line 4, we are actually removing students from the list of students array. We're pulling them out of this list. That's what the .pop is doing. And that's a method that we can do on arrays that just takes a value out and then it's no longer in the array anymore. So we're saying give me one value out of the array and then greet that student. So hi Matt, and then give me another value out of the array. Hi Susan, hi Sarah. We just grab each one of these values out of the array. And by removing the element from the array, we've made it smaller and smaller and smaller. At some point it's not going to have any more students and its length is going to be 0. And then students.length greater than 0, that's going to give us false. And that's when the while loop says, okay, it's time to stop. So that's a general, very brief overview of how you loop things, how you repeat things like process through a list of students. All right, let's try out a loop and see how this works. We've got a list of students here, and we've got a while loop that's going to loop over them and print them out. I switched it around a little bit just so that we can run it in our environment. When I click run here, you'll notice that we've printed Susan, Sarah, and Matt. That went in reverse order because pop is taking from the end, but there's a different method that we could have called on the array, and it's shift, which will take it off the front. So when I run it again, now we're going to see hello Matt, hello Sarah, and hello Susan. We have seen a number of times already, and you've heard me say over and over function, and some of you are like, why does he keep saying, what is a function? Well, similar to the idea of wanting to repeat things, there are times when we have a collection of statements, like a paragraph in a novel, but we want to do that multiple times at different places. Not multiple times in a row, but like do it one time, and then a little bit later do it again, and maybe a minute later do it again. And that's when we want to group that information into what we call a function. Actually, technically, the computer science-y programming term for this would be a procedure. It's a collection of things that we want it to do. So greet student, like the one we were using just a moment ago with the looping, greet student takes a student's name, a student object in this case, and we know it's an object because of line 3. You see student.name. That implies that student is an object in memory that has a property or a key called name, and we're going to go access that. First, we're going to access student, and then we're going to access the name property on it. So we're going to just print out hello, comma, and then whatever that student's name is. By the way, you'll notice these little backtick operators here. That's the sort of cousin to the double quotes and the single quotes. This is a special kind of string in JavaScript that's called an interpolated string. And I know that's a big mouthful, interpolated string. All that really means is a string where we're going to put other kinds of variable values directly inside of it. And that's what you see on line 3, that special $sign with the curly brace thing wrapped around student.name. That says go find whatever that is and just put it right in place inside of this string, which is why when we actually do the console.log, it would print out hello Matt or hello Sarah. So that's a procedure. It uses the word function to denote it, and it has a name called greetStudent, and it has, on line 1 there, it has student, that's called a parameter, that's the input to it, and it's just doing something, but you'll notice that it's not really giving us anything back. That's really why we call it a procedure, because it's not giving us anything back. It's doing something, which is important, but not giving us a value back. What's an example of something where it would give us a value back? Well, this is a little bit more truer to the spirit of a function, and functions is a special word that actually comes to us from math. And some of you may have heard of functional programming before. That's the idea of writing these things, not just that they do stuff, but that they compute values and they give them back to us. So here I have what's called a function called time remaining, and it takes 2 inputs now. It takes a time elapsed variable and an end time variable. Those have a special term. They're called parameters, the inputs to a function. And you'll notice that it returns us back, it computes an expression and returns us the value. So we say end time minus time elapsed, and then we say return whatever that value is. So if time elapsed comes in as 42, you see that on line 5, and if end time comes in at 240, then when we subtract those, subtract 42 from 240, what we have left, of course, is 198. That on line 5 we assign to the variable left, and then we see line 7 that value 198 is in there. So time remaining here is a function because it takes some inputs and it computes an output for us. It doesn't really go and do other stuff like print to the screen. It just says, let me do some work and give you a result back. Let me give you a computational result back. So let's try to run a function and mess around with the arguments and see how it changes. We know if we run it with the existing arguments, we get 198. But if I were to change this around a little bit, maybe say make that 140, then we're going to get a different result, 98. And what if I were to change this expression around a little bit? What if I were to make this expression divided by 2, and then all of a sudden, oops, we got a syntax error. That's important for you to be able to see the kinds of things that are happening in your program, and sometimes you make a mistake. I have an accidental parenthesis here, so I take that back out, we run it again, and now we get a different result. Okay, well that's a whole slew of different programming principles, and it might have just flown right over your head, but that's okay because we're going to take some time to practice it. In this exercise, you're going to get a chance to practice each of these different things, the values, the types, the loops, conditionals, the variables, all of those things. We're going to put it all together in one working piece of code. It's really important that you check out this README file and read through these instructions very carefully. I've tried to lay out exactly which steps you need to take to work through it, but I want to orient you to this exercise file so you understand. We have a variable here holding on an empty array. Favorite books is holding an empty array. And what you're going to be doing is you're going to be finding first an add favorite book function. You'll notice I'm already calling it here, and I've got listed several books that are going to be passed in. You're going to be defining that function such that each time it's called, it's going to add what you've passed in into this array. However, there's a little twist, which is that it's only going to add it into the array if the book title that's passed in doesn't have the word great in it. And you'll notice there are 2 of these book titles that have the word great in it, so those won't end up getting added, but the others will. The other 3 will. That's what add favorite book is going to do. And then print favorite books is going to do a loop. Remember we talked about loops. You're going to do a loop, and you're going to print out all of the books that are in this array. You're going to loop over all the values in this array and print those out. And you're also going to print out a message that says how many books are in there, which, as we just said, is going to be 3. Okay? So just make sure you follow along in these instructions, go in order, and make sure you check out the hints that I've labeled in each one of these items because they will give you critical information that you need. Refer back to the slides. All that information should be either in here or in those slides. And if you do get stuck, it's entirely okay because I know for some of you this may be some very early experience with programming. If you do get stuck and you need to kind of orient yourself a little bit, I have provided a solution file that you can take a look at and try to get back on track. So we'll take plenty of time on this, take as much time as you need, work through these types of things, and try to run the code. And by the way, use an environment that allows you to run code, like, for example, the Developer Tools console in your browser. One tool that I really really like to run my code. It's called run.js, and this is what it looks like. It allows you to type in some code like var x equals 42, and then console.log x, and then it allows you to click the run button, and then you see the output right there. So I really like this tool for running code, and that might be useful to you. But definitely do run the code as you're writing it so that you really get that hands-on experience with your code. Before you jump into this exercise and try to work on the code, I just want to make sure I re-emphasize that there really is no substitute for actually running your code and seeing the results. So as you're typing these things out, it's really important that you are also running them to try to see what results you're getting, what errors you might be getting to kind of correct things. That's how all JavaScript developers do it. So I want to show you real quickly a couple of different ways that you might do that. You could take some code and put it into the developer console of, say, the Chrome browser. So if you don't already have the Chrome browser downloaded, you can get that. If you've got something like Firefox, it's going to work very similar. I'm going to go up here and open up the developer tools for my Chrome browser, and I've got it on the console tag. If it's on the elements tag, just click over to console. But this is an environment now that you can actually write code. So I can say name, teacher name equals Kyle, and now I can see the results of what I'm typing. And then I could say console.log teacher name, and I can actually run that code and see the results of what I'm typing. So try your code in an environment like that. And if you don't want to use Chrome console or it's not working for you in developer tools, there's another tool that I really like to use, and it's called run.js. And it looks like this. It's an environment where you can type in, and then there's a button where you can click to run. So again, I could type in var teacher name equals Kyle, and then if I don't make typos, and then say console.log teacher name, and then when I click the run button, we see the results right there. So either one of those two environments, or if you have a different one, maybe you like to run your Node.js on a command line, but make sure you're running this code as you're trying the exercise. It's not good enough to just talk about code or write some code in theory in your head. What you really want to do is make sure that you're running that code and checking yourself and then correcting and moving forward. So try that on this exercise. We'll be back in a little bit to talk you through line by line through the solution. And remember, if you get stuck and you need a little bit of help, you can always take a peek at the solution file. I'm glad you came back and I didn't scare you away. So let's talk through the solution for this exercise. You may have gotten stuck on a few points, or there might have been some things that were confusing. So we'll take our time and make sure that we talk through each of these little bits. I'm going to walk you through these instructions, and then we'll switch over and we'll do the code. We'll run the code. We'll see those end results, okay? So you'll notice on instruction number 1, it says define an add favorite book function. Well, if you recall from our slides, and you probably saw it several times, the way we make a function is to use the function keyword. So over here in my exercise file, up here at the top where that code comment is, I'm going to take that one out and I'm going to actually define a function. We use the function keyword, and I'm going to say add favorite book. And then we need to receive some input. It needs to receive an input, a single parameter called book name. So I'm going to name it book name. Right inside those parentheses, that's a parameter. Now, just for the purposes of us testing, let's just print out whatever's been passed in. So I'm just going to say console.log book name. And then if we copy this code over into one of our run environments, I'm going to use run.js. If I run that code, you'll notice that it'll print out all 5 of them, because each time add favorite book was called, it's receiving book name, it's passed in, and then we're printing it out. Okay, now the second item in the instruction says, if the provided book name string does not have the word great in it with a capital G, then that's when you add it to the favorite books array. And there's several key hints here that you want to look at. Number 1, the hint says, if we want to figure out whether one substring is in a different string, then we say SomeString.includes in the another string, and that'll tell us if another string is inside of some string somewhere, okay? So that's the first thing that we want to do. We want to make a decision, and we remember we talked about decisions, we can use the if statement. So we're going to say if, and the thing that we're looking for is to see if book name includes, and then the thing we want to check for is whether or not it includes the word great. And that's when we're going to do something. But actually, this is backwards, because the instructions say only if it doesn't include. So we want to basically end up filtering out the ones that have great. We only want to do it if it doesn't include. And you might remember from our discussion of operations that the exclamation mark is how we negate or we complement a Boolean value. So if this one would have returned true, we want it to be false. And if it would have returned false, we want it to return true. So we're going to flip it by putting the exclamation mark there. So now I'm just going to do that console log statement again. We'll just make sure this time that we're only printing out the 3 book names that don't have the word great in it. So we'll switch back over to our run environment. We'll run this, and we should see only the 3 book names. And then we've filtered out, we have not printed out Great Gatsby or Great Expectations. Okay? So that allows us to see we validated that our if statement decision logic is working correctly. We can do the same thing in a Chrome console as we're doing in run.js. All right, now, the item says that we should be adding it to the favorite books array, not just printing it out, but adding it to the favorite books array. And here, this third hint tells us how to put something into array. We give the array name, and then we say .push, and we give it the value that we want to push in. So let's do that. Instead of console.log, let's actually just say favorite books.push, and what we want to push in is the book name that's been passed to us. So book name. Now, after all 5 of those have been called, then the favorite books array should have only the 3 in it that don't have the great keyword. So we could quickly check whether that was true by just printing out the contents of favorite books. After we've made these 5 calls, favorite books should have all 3 of them contained in it. Let's try that. I'll copy that code, come back over here to run.js, and when I run this code, we should see it print an array with those 3 strings in it. And sure enough, now we see an array with those 3 strings having been included. Okay, back to the instructions. Next item in our instructions said we want to make a print favorite books function. Well, we already know how to do functions. That's just the function keyword. This one's not going to receive any parameters. So let's try our hand at that. In this to-do statement, in place of the to-do statement, we're going to write a function called print favorite books. And it doesn't receive any parameters, so we just do that open close parenthesis. Now, I don't want to forget to take this console log out, so I'll remember to take that one out. We have our print favorite books function, and this is going to be called after we've done the add favorite books. So let's do that down here. Let's actually call print favorite books. And you remember that the way that we execute a function is we put a parentheses right after the variable name. That's how we execute a function. Now, the instructions tell us what print favorite books needs to do. It first needs to print out a message that says favorite books : and then it's going to have a number for how many are in that favorite books array. All right, so let's do a console.log statement, and we're going to be printing something out. And I'm going to use, because the hints tell us to use the backtick kind of string, that will allow us to include a value inside of another string. So let's use backtick, and then inside of this string, we're going to say favorite books with a colon. And then the way that we add a value inside of a string, the way we drop that value in is we do the $ curly brace delimiting. And then inside of it is the expression where we want to print out what is the number of the books. And the way we know the number of the books is going to be the length of this array. So we want to say favorite books.length. That's going to be the message that we want to print out. Let's just test this code as is and make sure it should print out favorite books 3 whenever we execute it. So I'll come over here and execute our code, and sure enough, we get the message favorite books 3. Okay, now back to the instructions. It says, finally, print favorite books should loop through that favorite books array. There's our keyword. We're going to be using a loop. It's going to loop through that favorite books array and print out each value. And we want to make sure, we've already done this part where we are calling the print favorite books function, and it gives us a hint here, which is critical. It says use the for of form. You remember in the slides, a few slides back, there were 2 ways of doing a for loop. One was where we were counting with an I variable, and one was where we were just getting all the values in an array. It's going to be easier for our purposes to use the second form of that, which was this for of loop. So let's do that. Let's go back to our print favorite books function, and we'll type in for, and we need to declare a variable. So we'll say let, and we're using let here just so that we add the variable only in the for loop instead of the function. Either way, you could have used a var if you prefer, but I'm going to use a let. We're going to say for let, and then we want to say book name of, and then the thing that we're going to get all the values out of is favorite books. That's our array. So we're going to say for let book name of favorite books, and then we're going to do console.log book name. Now, if we test this, we're expecting it to first print out favorite books 3, and then 1 line at a time, we're expecting it to print out only the 3 books that are in our favorite books array. If we've done our jobs correctly, this application should work now. So I'll switch over one last time to run.js, and we will run this code. And there we go. It says favorite books 3. Let me move it over so it's a little easier to say. Favorite books 3, A Song of Ice and Fire, Crime and Punishment, and You Don't Know JS. Those are clearly the 3 best books that have ever been written. All right, so hopefully you're feeling a lot more comfortable with some of these basic programming principles. If things were a little bit confusing for you, that's okay. Try this again. Try the exercise from scratch. Just start over from the empty file and try going through the instructions. Maybe try, if you were able to get the exercise working from up to the point of the solution, maybe try adding something. Maybe try add some more books, or add some more calls to add favorite book, or maybe try filtering out a different value from the book name or something like that. Play around with this code a little bit. Don't be afraid to actually write some JavaScript, because there really is no better way of learning how to code JavaScript. Now that's our big kind of high-level overview of the ideas behind programming. And I just want to call you back to, this is all the kind of stuff that we dig into in much more detail than just now in Chapter 1 of the Up and Going book. So I strongly encourage you to kind of go through that chapter after you've watched through this part of the course, go through that part of the chapter and just try out the different code. It's great for you to actually program along with it instead of just reading or just listening to me talk. You want to actually go through and try out each of these things and get your brain really wrapped around these ideas of values and operations and things like arrays. We need to figure out how to work with those, because you're going to see those a lot in the rest of your program. So you want to then be able to do loops and decisions and even make your own functions. So definitely check that stuff out, and then you'll be ready to move on to the next part of this this course, where we're going to dive into the deep principles, what I call the 3 deep pillars principles of the JavaScript language.